Hi everyone and welcome to this lecture. In this lecture, we're going to be going over Kotlin interfaces and abstract classes. Okay, let's get started with interfaces. What are they? An interface in Kotlin is like a set of rules or a contract. It tells classes what actions they must be able to perform, but it doesn't say how to perform them. Abstract methods are like blank spots in the rule book that classes must fill in with their own specific instructions. Default methods are like rules that already have a default action, so classes can use them as they are or provide their own version. Simply put, you can imagine an interface as a list of tasks. If you agree to follow this list, you have to complete all the tasks, but you can decide how to do them. Some tasks might already have suggested ways to do them, which you can use if you like. Next, abstract classes. What are they? An abstract class in Kotlin is like a blueprint that is partly finished. It has some parts already built with regular methods and some parts left for other classes to complete with abstract methods. Abstract methods are parts of the blueprint that are not complete, and derived classes must provide the details. Concrete methods are parts of the blueprint that are already complete and can be used as they are. Simply put, you can think of an abstract class like a half-built house. Some rooms are already constructed, but some are just empty spaces that you need to finish yourself. You can't live in the house until it's fully built, which means you can't create objects from an abstract class directly. In summary, interfaces are like rule books that specify actions classes must perform without providing the details on how to perform them. Abstract classes are like partially completed blueprints that provide some implementation and require subclasses to complete the rest. Simply put, interfaces and abstract classes help you design your program structure by defining what actions classes should take and providing shared functionality that multiple classes can use, making your code more organized and reusable. Finally, let's go over the differences between these two once more. Rules versus blueprint. Interfaces are lists of tasks, rules, while abstract classes are half-built houses, blueprints. Multiple versus single. You can follow multiple interfaces, task lists, but only one abstract class, blueprint. Usage. Neither can be used directly. Interfaces need classes to follow the rules, and abstract classes need to be completed before use. In the very simplest terms, interfaces are like multiple to-do lists you can follow simultaneously, while abstract classes are like single, incomplete blueprints that need finishing touches before they can be used. Alright, let's dive into some code examples. Cool! Let's get started with an interface example. Here we have a code snippet, interface, drivable. We have two functions here, drive and stop, and a print line, a string of text that says the vehicle has stopped. So an interface right here defines a contract for what a class should do but doesn't provide the implementation. It can have abstract methods like drive that must be implemented by classes and default methods like stop that have a default implementation. So here you can see that it has a default implementation. It will print this line. And in the other one, it doesn't. Okay, it needs to be implemented by classes. So an interface is like a rulebook. It tells classes what they must be able to do, like drive, but doesn't say how they should do it. Some rules can have default actions though, like stopping. Next, we have an abstract class. We have abstract class vehicle, okay? An abstract class can have both abstract methods, like start engine, right here, that must be implemented by derived classes, and regular methods, like honk, with implementations. Abstract classes cannot be instantiated directly. An abstract class is like a partially completed blueprint. It provides some parts that are already built, like honk, but leaves some parts unfinished, like start engine, for other classes to complete. Here we have a concrete class implementing interface and inheriting from abstract class. So the concrete class here is car, and this class inherits from the vehicle abstract class and implements the drivable interface. It provides specific implementations for the abstract methods, like start engine and drive. The car class takes the partially completed blueprint from vehicle and finishes it by building the engine. It also follows the rulebook from drivable by providing how it drives. This is another concrete class implementing the interface. So the bicycle is the concrete class. This class implements the drivable interface and provides an implementation for the drive method. It doesn't need to inherit from an abstract class. The bicycle class only follows the rulebook from drivable, providing its own way to drive. Lastly, let's go over everything that we just went through in this main function example. So first, we create a car object. This line creates a new car object with the brand Toyota. The car class inherits from the vehicle abstract class and implements the drivable interface. Next, we start the car engine. This line calls the start engine method on the car object. The car class has its own implementation of start engine, so it prints the Toyota car's engine is starting. Next, driving the car. This line calls the drive method on the car object. The car class has its own implementation of drive, so it prints the Toyota car is driving. Next, we stop the car. This line calls the stop method on the car object. The drivable interface provides a default implementation for stop, so it prints the vehicle has stopped. Next, we have honk. This line calls the honk method on the car object. The vehicle abstract class provides the honk method, so it prints the Toyota vehicle is honking. After that, we create a bicycle object. So this line creates a new bicycle object. The bicycle class implements the drivable interface. Next, we write the bicycle. This line calls the drive method on the bicycle object. The bicycle class has its own implementation of drive, so it prints the bicycle is being ridden. Lastly, we stop the bicycle. This line calls the stop method on the bicycle object. The drivable interface provides a default implementation for stop, so it prints the vehicle has stopped. In summary, first, we create a car and see how it can start its engine, drive, stop, and honk. The car follows both the vehicle blueprint, okay, and the drivable rulebook. In addition, we create a bicycle object, we create a bicycle, and we see how it can drive and stop. The bicycle follows the drivable rulebook. In simple terms, this main function shows how different objects, a car and a bicycle, can perform actions like driving and stopping by following shared rules, interface, and specific blueprints, abstract class. Thank you so much for joining me on this lecture. I hope this was helpful to you. Make sure that you go over the code in the description below this lecture. Treat yourself to a break, have a cup of tea, have a cup of coffee, and before you know it, I'll see you in the next lecture. Thank you so much.